Hello class, welcome to today's lesson dealing with polar graphing and equations. This is our last lesson in section 8.5. We're going to go over some review questions of things we've done the past few days and also look at some graphs and explain how the graphing aspect works in polar graphing. There won't be a ton of graphing pieces that you have to deal with right now, but I at least want to introduce some of those ideas to you. Okay, just a few reminders. These are the equations and conversions ideas for rectangular to polar, so you want to make sure that you understand how those are set up. Okay, these four things are the only ones that you can use. The first two are more used if you have polar and go to rectangular. The last two would be used more if you have rectangular and want to go to polar. Okay, so this is a polar coordinate. So to graph the point 8 comma negative 90, that would be 90 not upward, but downward, so kind of clockwise downward. So that would put you down here at 270. Then you got to go 8 from the center, or a distance of 8. My graph paper only goes to 6, I believe, so I have to go further out, so that's why it's kind of off my graph paper a little bit here. 8 comma negative 90 would be the same as 8 comma 270, because you could just add 360 to it, and it's the same answer. That's also the same as if you go the other direction to 90 and go negative 8, because it would be going in that upward direction, but then it ends up downward because it would have a negative r value. To figure out the coordinate of this one, you could do r cosine theta. So you plug in r as 8, cosine of negative 90, that's 0. 8 sine of negative 90 is negative 8. And if you think about it, that makes sense. If you look at an xy coordinate plane, this would be 0 to the left, right, and 8 down. That's why that point would end up being negative 8 for the y value in that situation. The next question is just switching from a rectangular equation to a polar equation. Remember, x equals r cosine theta, y equals r sine theta. Once you get to that point, you probably have to get r by itself, kind of like when you get y by itself for an equation of a line. So you factor out an r from both of these pieces, so put r up front, and then divide by the cosine and sine piece, and your answer will be this fraction, 6 over 2 cosine theta minus 3 sine theta, and that would be your final answer in that situation. Okay, now we come to graphing. This looks like a lot of information, but really it's very straightforward, and it's just a matter of connect the dots. So really what you're going to do is just make a table of values. If you think way back to when you first started graphing lines or any equation, the first way that we always learn how to graph is just plugging in points, finding the y value, and graphing. So we're going to do the same thing here. We plug in the theta value, find r. So I just plugged in all these numbers. I plugged in 0, 30, 45, 60, and then all of their multiples going all the way around the circle one time. And then I get answers of 3, 2.9, etc. What you'll notice here is, notice that this goes 3, 2.9, blah, 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 all the way to 1.1 and 1. And then there's probably a pattern to it. It may not be exactly halfway. It may be kind of the first and the second half. It may be the first quarter and the second quarter. But there should be some type of pattern to it as you keep moving forward. So for this question, you'll notice that at 150, it's 1.1, and so is 210, and then it goes back up, okay, all the way back to 3, which means it's symmetric above and below the y-axis, essentially, okay? And then you just plot the points and connect the dots. So 0, 3 is this point right here. 2.9 with 30 is right here. 45 is not on your graph. You just have to estimate halfway between 60 and 30, and you keep going, and this makes kind of a like an odd circular kind. It's a bean shape. Also known as a limacon sometimes, but it should be kind of an oblong, like oval that kind of it could be indented on the one side. And anytime there's a plus or minus like this, it's going to have that weird, that interesting shape like that. It's kind of weird, but it's not quite circular, but it'll be close. The next two graphs are the best graphs for polar graphing. They're called rose petals. What you'll notice here is you're going to get a lot of whole numbers and integers as I plug all these numbers in. 0, 4 is right here, and then 32, and then 45, 0. The key is you have to think, if you've ever seen those old spiral graphs where you keep moving and keep moving, this is not draw the pedal, then draw the next pedal, etc. It's one continuous line. So it starts here, it kind of goes to the middle, and then at 60 it goes -2, which would be here, and then -2 or -4 for 90, back here, and it loops around. And so if you draw as you go, you get this nice rose petal that has 4 petals, and it has 4 distance out from the center. Now, this is the same idea as amplitude. The 4 here represents how far out from the center it goes. So it goes 4 out. So that's the distance or the length of the petal. Now there are 4 petals because if the number inside by the theta is even, there's twice as many. So if this was 8 theta, there would be 16 petals. Since it's 2 theta, there's 4 petals. And that works if it's even. But remember that these pieces are always developed by one continuous line. So I don't have to pick up my pencil ever to draw this four petaled rose graph. The next one is 2 cosine 3 theta. What you'll notice here is there's a 2 out front, so that means everything has to be 2 away from the center. This one's a little bit more challenging to draw just because there's less petals and the numbers don't work out as well. It still does the same idea. It starts here, kind of comes to the middle, goes out and around and back. But there's only 3 petals here. And it's because of the nature of there's an odd amount being multiplied by theta. That deals with kind of odd and even functions and things like that we don't need to go into right now. But if the number inside the cosine function, or the sine function, is odd, then that's the number of petals. So if it was 11 theta on the inside, there'd be 11 petals. And you can make some really cool looking graphs. And if you think about it, this would allow us to graph things like a propeller, for example, or a fan without having to deal with XY coordinate plane because those would not fit the vertical line test. So it'd be hard to graph and make into some type of equation. It's much easier to make that type of graph in a polar version, because of the nature of the circularness of the object. R equals 5 is very easy. That's a circle with radius 5, so I just go out 5 for 5th ring and just draw a circle. That's the easiest polar graph there can be. Okay, that's the same as x squared plus y squared equals 25. But a radius of 5 should be very easy to find. And then one of them that's also cool is r equals theta. And I haven't drawn anything to scale, but r equals theta, just think about it. As theta increases, r increases the same amount, so it's just constantly going up. So this would be a spiral that goes on forever outward. So a spiral idea would be from that situation. Remember, for polar graphing, it's just plug some points in. If you have to look at a graph and figure out which one it is, use the number of petals like this one, the distance for the center maybe like this. It's more the bean shape like this one. You want to just plug some points in and see which one matches. But the focus is going to be more on these other questions, figuring out kind of what, switching the format, and honestly just knowing where the graph ends up in a polar coordinate system plane, and also how to switch that between rectangular and polar. Have a good day, everyone.